Okay, thank you very much for joining us today. My name is Albert Garcia. I'm a librarian with the Contra Costa County Library, and I'm very happy to have you here today for our program. Today's program is sponsored in partnership through the Contra Costa County Library and 350 Contra Costa. Today's program is the third in a series that took place this week. All three programs are being recorded and will be available on the library's YouTube channel. Everybody who registers for these three programs will get an email with that link. In just a moment, I'm going to hand it over to Jackie from 350 Contra Costa, but I do have a couple of things to go over before then. You have been muted and your cameras were off. You can turn them on if you want, but please do stay muted until the question and answer at the end of the program. We have a survey we're dropping into the chat. Is that right, Jackie?
I don't have it with me. I'll have to get it unless you have a copy.
I'll look to see if I find it. We have a survey that I'll go over a little bit later, but I also want to point you to the top right-hand corner. There's a grid view. You can do a grid view or a speaker view. We are going to spotlight the speakers, so you can go to speaker view. After we stop spotlighting the speaker for the Q&A, you can go back to the grid view at that point. Just going to share a different kind of screen now. And let's see. Give me just a moment to start this.
Sure, no problem.
All right, thanks. Okay, in just a moment, I'm going to hand it over to 350 Contra Costa. Before that, I do want to talk about a couple things that we have going on here at the library. The Contra Costa County Library is happy to connect you with our resources, services, and materials at all 26 of our branches. Access more than 1 million physical items, including international language collections and thousands of digital materials 24/7 at ccclib.org. Visit any library to use our public computers, printers, and free Wi-Fi. You can also visit one of our branches with laptops for on-site use, or check out a Wi-Fi hotspot for 3 weeks. Contra Costa County Library's adult literacy program trains and supports volunteer tutors to deliver basic literacy instruction to adults throughout the county. Visit our website and sign up for a digital library card today. And now I'm going to go ahead and hand it over to Jackie and 350 Contra Costa.
And Albert, if you don't mind, if you could mute our participants, of course, except for Alana. We're hearing somebody's background noise, but I'm not even sure who it is. It's a little strange. There, that's better. That's good. Okay, everybody can hear me though, right? Well, thank you for joining us today. I'm Jackie Garcia Mann with 350 Contra Costa. And in honor of Walnut Creek Sustainability Week, we are doing a series of 3 talks. We've just finished 2. And as Albert said, you can access them later on the library YouTube channel or on the 350 Contra Costa channel, but that might take another week before it comes out on ours. The first one was on electrifying your home, and there was a lot of good data on that. And then the one yesterday that I did was about climate solutions and how to be a climate advocate. And today we have Ilana Weissman from 350, and she's going to describe something called a carbon sink. And this might be a new term to many of you about storing carbon and what we do with the excess carbon in our atmosphere. And Albert, I just have one other question. Are you able to mute the sound as people come into the room so we don't hear the ding dong? Okay, great.
That I don't know about, but I'll try. I'll look into that.
Okay, all right. And then Ilana, if you want to go ahead and share the screen.
Will do.
Okay.
Okay, here's my slideshow.
Yep, you're sharing. And so now, there you go. It looks great.
Okay.
I'll mute myself now.
Right, so we're going to be talking about carbon sinks, natural and otherwise. And this is it's going to be a very basic, high-level, non-technical presentation. The idea is just to ground you in the basics of carbon dioxide capture. This is an important and controversial topic. Newsom's plan to reach net zero carbon by 2045 calls for technological carbon capture methods as essential tools. The Federal Build Back Better Act and the Inflation Reduction Act are allocating billions of dollars in tax credits and direct funding to these projects. However, many scientists, engineers, and environmental activists are highly skeptical that the projects will work as planned or be worth their extremely high cost. Nevertheless, a major technological carbon capture project is being proposed for Contra Costa County, and I will get to that later. Okay, so what are carbon sinks and why do we need them? So when we talk about carbon sinks, we're really talking about carbon dioxide. And there's two major categories of removing carbon dioxide from the air. One is the natural methods that are based on the carbon cycle, and the other are the technological methods. And we need to decrease carbon dioxide particles in the air, as I'm sure you know, because they are the culprit in global warming. And it's humans who are responsible for the increase in CO2 particles and for the resultant global warming that we are experiencing. Of course, we also need to switch to fossil fuel-free fuels. There's no way that we can use carbon sinks to get to where we need to go by as soon as we need to get there. So switching to fossil-free fuels is really the most important thing that we can do. But carbon sinks can also be helpful. Okay, so for the natural carbon sinks, they're based on the carbon cycle. I'm going to change my view here, so if I can, no, I can't. Anyway, so this is the carbon cycle. As you can see, there's fossil fuel emissions. I don't know why there's a typo in this graphic. So the way CO2 get into the air or from there, then there is a process called respiration where the energy within plants, and I think also within animals, is broken down. You know, it's stored as carbohydrates. It's broken down to release the energy, so it can be used by the organism. And in that process, CO2 is released into the atmosphere. There's also a certain amount of CO2 that is released or evaporates from the ocean. And the way we sink carbon dioxide naturally is through photosynthesis, which is a strong way of doing it. Also, decomposition and waste can be captured by the soil. It can be captured by the ocean and by glacial and polar ice. So these are pictures of natural carbon sinks. Although all plants, all green plants use photosynthesis and thereby store some carbon. Obviously, trees are big and long lasting, so they're especially good carbon sinks. Okay, in case you're a little fuzzy on high school biology, this diagram explains how photosynthesis takes CO2 out of the air. The plant, the leaves absorb sunlight, the leaves take in carbon dioxide from the air, the roots take in water. Together, they make carbohydrates that store within the chloroplasts, and those carbohydrates are energy stored to be used later by the plant for its metabolic processes and to grow. When those carbohydrates are broken down, they release some CO2 and some oxygen into the air. Okay, so trees as carbon sinks, obviously long-lasting and big. When trees shed leaves, branches, and other organic materials, these contribute to the accumulation of organic matter in the soil. And this organic matter contains carbon that is then stored in the soil, which can remain there for extended periods. especially in forests with rich, well-developed soils. The obstacles in increasing the use of trees as carbon dioxide include the fact that they require land, they require water, and they require money to pay for the labor of planting them and for nurturing them and for acquiring the land and acquiring the water and acquiring the trees. Also, as we all know, wildfires are massive releasers of CO2. Decomposition of trees also releases some CO2, which may or may not be captured by the soil. So the ongoing research is to quantify how well trees and forests capture carbon and determine the best species. And China is actually experimenting with some large afforestation projects and conducting research on these questions. Soil as carbon sinks. Okay, during decomposition, a portion of the carbon from the organic materials is incorporated into the soil as organic carbon. And plants release a variety of carbon-containing compounds known as root exudates into the soil. These exudates, along with carbon-rich substances from decaying plant roots, provide a food source for microorganisms in the soil. And these microorganisms use the carbon to build their own biomass, which becomes part of the soil's organic carbon pool. Soil particles can physically protect organic matter from decomposition by forming aggregates that shield the carbon from microbial activity. This physical protection can also help store carbon in the soil for longer periods. And humus is created over time from partially decomposed organic matter in the soil, and it is a stable form of organic matter in a complex mixture that can persist in the soil for decades to centuries. So it can serve as a long-term reservoir for carbon. The primary obstacle to using soil as a carbon sink is agribusiness. Agriculture, particularly of large-scale monoculture type that is characteristic of agribusiness, depletes the carbon in the soil. There are existing methods to enrich the soil's carbon, which include no-tilling and using cover crops, and there is ongoing research to improve these methods. There's also some movement to leave post-agricultural land unused, thereby allowing a natural plant succession to occur, which would lead to photosynthesis and decomposition. Oceans as carbon sinks. The ocean surface, and of course, most of the Earth is composed of ocean, absorbs atmospheric carbon dioxide, which then dissolves into the water. And this creates carbonic acid. And this process helps in regulating the amount of carbon dioxide in the air. Phytoplankton are the tiny marine plants that are found in the upper sunlit layer of the ocean, and they play a crucial role in the carbon cycle through photosynthesis. When these organisms die, they fall to the ocean floor, taking the carbon with them and effectively removing it from the surface water so that it cannot vaporize into the air above. And ocean currents act as a physical pump in transporting surface water that's rich in dissolved carbon dioxide to the deep ocean, and that allows the carbon-rich water to be stored for extended periods. And there are some chemical reactions that occur within the ocean that result in the conversion of carbon dioxide into carbonate ions and bicarbonate ions. These reactions effectively remove carbon dioxide from the ocean surface and facilitate its long-term storage in the ocean. The concern with attempting to increase the amount of CO2 captured by the ocean that it involves producing carbonic acid and that leads to ocean acidification, and that is bad for marine life. So there is research going on in trying to prime carbon uptake by seeding the ocean with minerals, and also there's work to encourage seaweed growth, because seaweed is a pretty fast and inexpensive way to have photosynthesis occur and uptake of carbon dioxide. Ice is the carbon sink. Of course, what we're talking about is glacial ice and the polar cap ice. And as snow accumulates, it traps and compacts over time. It can trap air bubbles that of various gases, including carbon dioxide. And glaciers erode rocks and soil as they move, carrying and depositing organic matter and carbon-rich sediments downstream. So this process transports carbon from the land to the seas, where it can be stored for extended periods. And ice has the potential to preserve trapped carbon for long periods, sometimes even for thousands of years, depending on the conditions and the depth in which the carbon is stored. As we all know, glaciers and polar ice are melting pretty fast and thereby releasing carbon, CO2 into the air. So that's the con. There's some research done into trying to slow melting by cooling down the planet through creating artificial clouds by seeding in the air. And these really haven't gained any traction because of the likely negative unintended consequences. So I like this this graphic of the carbon cycle, even though it's somewhat dated, because it makes it very clear that the burning of fossil fuels is the reason why greenhouse gases and carbon dioxide, one of the greenhouse gases, are increasing in the air, and thereby why the climate is warming. So atmospheric growth on an annual basis is about 4.3 gigatons of carbon dioxide. That means sources minus sinks. Burning of fossil fuels contributes 8.9 gigatons. So if we had no burning of fossil fuels, we would actually be in a net atmospheric growth of carbon. We would actually be able to draw down greenhouse gas. Okay, carbon capture and storage, and those are technologies and methods designed to mitigate the release of carbon dioxide into the atmosphere from large-scale sources such as power plants or industrial facilities. So most of the methods of capturing increased amounts of carbon dioxide using natural carbon sinks are long-term in nature or have obstacles to their implementation. Newly planted trees will take a while to be large enough to store significant amounts of carbon dioxide. Improved farming methods may be outcompeted by soil depleting agribusiness. So, of course, governments are turning to technological solutions. These have the advantages from the government's point of view and from the oil industry's point of view of allowing power plants, oil refining facilities, and other factories to conduct business pretty much as usual, continuing their reliance on burning fossil fuels. Major oil companies such as ExxonMobil have been enthusiastic backers of research into carbon capture and storage. So there are 5 main categories of carbon capture and storage methods. I'm going to go over each one. Pre-combustion capture involves converting fossil fuels such as coal or natural gas into a mixture of hydrogen and carbon dioxide before combustion. For example, In gasification processes, coal is partially oxidized in steam and oxygen under high temperature and pressure to form a synthesis gas. The CO2 is then separated from the hydrogen, with the hydrogen being used as a fuel source. While this is a fairly efficient carbon capture method, building the gasification infrastructure is expensive, and the high temperature oxidation process is energy intensive. And this is something that would occur at the site of one of these factories and refineries that we're talking about. So another on-site method is post-combustion capture. That involves removing CO2 from the exhaust gases produced by burning fossil fuels. And it typically uses chemical solvents or other technologies to capture the CO2. It's expensive, energy intensive, can result in increased particle emissions, and can have significant risk of accidents. Oxy-fuel combustion involves burning fossil fuels in pure oxygen rather than air, resulting in a flue gas being what's given off after the fuel is burned, that is composed mainly of CO2 and water. The CO2 can then be separated from the water vapor for storage for other uses. There's a very high energy requirement for producing high purity oxygen, and very high temperatures are produced by combustion in a pure oxygen environment with a high risk of CO2 leakage. Okay, now we're turning to methods of carbon capture and storage that take the captured carbon off-site. We're going to talk about carbon capture and sequestration, and I'm abbreviating that as CCS. There's a little ambiguity in the literature. Sometimes CCS means carbon capture and storage. Sometimes there are different abbreviations you'll see, but we'll use CCS. Okay, so the carbon's captured on site, and then it's transported to a suitable storage location, usually through pipelines. The captured carbon is injected into geological formations such as depleted oil and gas reservoirs, saline formations, or unminable coal seams. The amount of currently available suitable geological storage space is pretty limited. Liquefying CO2 requires high pressure and a lot of electrical energy. This is another expensive, energy-intensive carbon capture method that can result in increased particle emissions and have a significant risk of CO2 leakage. Enhanced oil recovery, or EOR, is a special case of CCS, where the captured CO2 is used to increase oil production. So this is the most widely used CCS method. It's similar to fracking, where the CO2 is injected into what seem to be depleted oil wells to get the last remaining bits out. It's different from fracking because the CO2 just scrubs the existing fissures in the rock rather than creating new ones. EOR causes environmental damage through disturbance of the land, deterioration of surface water quality, contamination of groundwater aquifers, and air pollution. So the general critiques of carbon capture and storage are, first of all, the methods have been used only on relatively small projects. So we're talking about scaling up to millions, maybe billions of, we're talking about scaling up to gigatons of carbon capture, which definitely hasn't been tried yet. As of 2021, more than 80% of the 39 carbon capture and storage projects in the US have failed, which is not so surprising given that they are new technologies. And all of them require use of substantial energy, but the projections that are made generally do not consider what the costs in terms of money and environmental damage are for producing the energy that then needs to be used for these carbon capture and storage methods. They often, and I'd say usually, are situated in disadvantaged communities that are already struggling with pollution, and this is just subjecting them to potential further pollution. Regulations have not kept up with these new methods, and the pipelines that transport CO2 need to be manufactured to a higher standard than ordinary gas pipelines, because the carbon dioxide is under pressure and it's corrosive when it's contaminated with even a small amount of water. And there are no regulations for CO2 pipelines. The responsible federal agency is promising to come out with them next year. And here's a little diagram showing the overview of CCS and enhanced oil recovery. And there are a number of ways in which this process can lead to CO2 leaks and environmental damage. As I mentioned, transported CO2 can be corrosive and cause pipelines to leak. Also, CO2 is injected into the geological formations under very high pressure, and it's cold. So under normal temperatures, it's a gas. So as it warms up, it tries to force its way out of any cracks in the geology. And that leads to a potential for contaminating nearby wells, surface water, basements, and the air. And as far as how long we can store CO2 in these geological formations, we simply don't know. Okay, so as I told you, there is a project that is being proposed for Contra Costa County. The project is going to collect and sequester millions of tons, or at least 1 million tons per year of CO2 from multiple power plants and industrial sources located within 45 miles of the site, which is in the Delta, the Sacramento Delta. It's going to transport CO2 by barge to begin with. And the proposal is to also build underwater pipelines to the existing offloading deck on the Sacramento River, and then use on-site pipeline to the proposed injection site, which is a mile north of the dock. And the proposal is that this project will last 40 years, at least 40 years, sequester 1 million tons of CO2 for 40 years. Here is the proposals stage 1, and I'm going to try and turn on my laser pointer here. Okay, so I'm having a little problem with my screen, but it's going to take oil from the PG&E, take captured carbon from the PG&E plant and from the Calpine Delta Energy and Calpine Los Medinos power plants, and use barges at first, and then go to the dock by the Montezuma Wetlands, go up through underground pipeline to the injection site. And this is, I go back, sorry. So this area is the Montezuma Wetlands injection area where the carbon's going to be stored. Oh, and I should say, by the way, that this project is a joint project of Jim Levine, who is the landowner, Lawrence Berkeley National Lab, Lawrence Livermore National Lab, in other words, with funding from the Department of Energy and of PG&E. And in stage 2, it would greatly expand. These brown underwater pipelines that would take captured carbon from Chevron, from wherever this is, which I can't really read, Air Products Martinez hydrogen plant, the PBF refinery, the Marathon refinery, the Valero refinery, back to the wetlands. And okay, let me turn off this. Okay, so there are major health concerns for CCS projects. And if you don't remember anything else about CCS projects, this is an important thing to remember. Okay. Carbon dioxide is an asphyxiant, which means it is heavier than air, and it blankets the surrounding air so that it forces out the oxygen in the air, and it's a colorless and odorless gas, and it does not disperse by itself because it's so heavy. If there's wind in the area, or if it's on a hill and there's gravity pulling it down, it will disperse, but if it's in a lowland area, it'll just stay there. Because it is depleting the oxygen from the air, even really low levels can cause brain fog, dizziness, nausea, headaches, and trouble breathing. High levels can kill, and I've read that even 1 or 2 breaths of pure CO2 can kill you. And CO2 is corrosive when it's contaminated with water, and that's often true with the various carbon capture and storage methods. And it's sometimes contaminated with other toxic chemicals. And stored CO2 converts to vapor under normal temperatures. So it tries to escape any fissures that there are in geological formations to contaminate walls, surface water, and basements. And in 2020, the world, well, it wasn't the first one, but the US experienced a CO2 leak. This leak occurred in a tiny community called Satartia in a very disadvantaged part of Mississippi. What you see on the ground is a powdery white. What happened is that a powdery white cloud was leaked. It then fell to the ground as a powder, very cold powder that could actually make steel so brittle that it would shatter. And then as it warms up, it forms the heavy vapor that's an asphyxiant. So people who were inside the cloud were nauseated and gasping for air, and some 24 people collapsed in their homes, a nearby fishing camp, and in their vehicles. 250 people had to be evacuated. 49 of them were hospitalized. Many have continuing respiratory problems. The CO2 in this pipeline was contaminated with deadly hydrogen sulfide, and that's not rare. And of course, it worsens the health impacts. Okay, and another concern we have about the Montezuma Wetlands project is that we have earthquake faults in California. So I'll turn on my laser pointer here. This is the something which Pittsburgh Kirby Hills Fault. This is the Sherman Island Fault. This is the Potrero Hills Fault. Here's the Vaca Fault. And this is the wetlands area, and here's the injection site. Down here, you see the question marks in the circle, and what that's about is that we really just don't know whether there are faults in this area. Okay. So more concerns about this project. There are lots of wells and legacy oil wells around. The wells could be contaminated. The legacy oil wells could serve as conduits for the CO2 getting to the surface. And they are sited near, the project is sited near low income and disadvantaged communities. There's actually a very small community called Collinsville that is near the southern border of the Montezuma Wetlands itself. Pipelines, the proposed pipelines would go past Pittsburgh, past Richmond, past Crockett. All these communities already have struggles with pollution. There's a potential for contamination of wetlands. And should the wetlands become contaminated, it would be rather ironic because Jim Levine, the landowner, got kudos for restoring these wetlands in the first place. And it has a potential for contaminating nearby farms and ranches. And at the moment, offsite CO2 pipelines are not legal in California. It's okay to have a pipeline within your facility that carries CO2, but not offsite facilities. So of course, the project would have to get waivers from California regulatory agencies. And what is next for this project? The EPA's ruling about a permit is likely a year away. This I put up on the screen where you can find the application. Montezuma could start the California Environmental Quality Act, CEQA, and Low Carbon Fuel Standard, LCFS processes to get the project approved under these acts. There will be opportunities for public comments at this point. We don't know when, and we don't know, it's not clear who the lead agency will be. We definitely need to press for better regulations and safety guardrails for CO2 pipelines. Hopefully they're coming in 2024, and we need stronger protections for wetlands and farm ranch lands. Okay, and that is the end of my presentation. So I would appreciate starting the Q&A session by asking, turning around and asking the people who are attending some questions, which one of them is, this is the first time I've given this presentation, and I'm interested in knowing what you expected to learn and whether you think you learned it. So could someone, I guess I'm going to call on Narissa because I know her and ask her.
Yeah, you did that with my mouth full.
Oh, I'm sorry.
I'm just joking. It was, I mean, it got way more specific than I realized it was going to get by going into, I didn't know it was going to go into this depth about the Montezuma project, which was all new information for me. So I find it interesting, you know, it's interesting and a little concerning that, Lawrence Berkeley Lab and Lawrence Livermore Lab are participating in this. If that's really where they think the science needs to go, it's kind of, it's a little scary.
Yes, I would tend to agree with that. Anyone else? What were you expecting?
Susan.
Well, I was coming to this hoping to hear something more optimistic. That's what I was looking for. It seems not.
I would say that, it's not a great fixture for carbon capture methods. And what it really underlines is that we have to move faster to get off fossil fuels. Right. I mean, we got to go to the renewable energy sources that's a supply side. And then there's the demand side where we need
Right.
better public transportation systems. We need to stop consuming as much. So we stop needing to use as much energy as we're using.
Thank you.
Oh, Mary, you want to take yourself off mute?
I was expecting it to be more about trees and gardening. This was
Ah.
very exciting. And can I ask you a question?
Sure.
Are those earthquake faults, do they include the one that just happened, the earthquake that just happened at Ileton?
I don't think so, but I don't know for sure.
Thanks. Very interesting. Scary.
Yeah.
Alana, I thought you could have gone into a little more about the money behind this, the backing behind this idea, and slides with pictures about how basically it's the fossil fuel interests who are pushing this solution, because they want to do it for two reasons. One is to keep in business. They want to keep burning fossil fuels. So if they can bury their own pollution, then they have the excuse to keep on burning at the same rate. And the other is, you know, a little more about the enhanced oil production part. And there should be lots of pictures of that available online, you know, from actual places where they're injecting CO2 into wells.
Okay.
People have questions too. You're welcome to take yourself off of mute.
Has anything happened due to the that incident that happened in Louisiana?
Well, it did motivate the federal agency to think about the rules. I mean, I think that's why they're working on the rules, the regulations for the pipelines now.
Yeah, there's an organization called the the Pipeline Safety Trust. So they have their annual meeting in New Orleans because there's a lot of pipelines there. So they're looking at federal regulations on CO2 because, as Alana said, it's very corrosive and it's very poisonous. So if you have a leak because your pipeline corroded, anybody near that leak would likely suffocate. And then we also don't really understand how, if there are leaks throughout the, you know, from the earthquake faults or old gas wells, how that would affect the water table or the wetlands. You know, what happens if this leaky gas starts sneaking its way out of cracks in the earth? Oh, you know what else, Alana, would have been neat to see are the pictures of people who are turning CO2 into cement, because that's a more permanent solution. And there's a lot of companies that are trying to store CO2 as cement or as rock, especially in Iceland. There's a lot of that. And that technology seems to be safe and permanent, but again, it's very high energy. And so you need a really cheap green energy source to fuel it.
That's good.
Is anybody here involved in natural carbon solutions, storing carbon in agricultural areas or forests? No. So a lot of state and federal legislation that has passed on that recently. All right, anything else you want to put in closing, Alana?
Yes, this, as I said, we need to understand that what's being proposed for Contra Costa County is a bad idea. We need to be ready to
Mhm.
to respond when there are hearings
Mhm.
from what we understand now about the risks.
Mhm.
And we need to continue to advocate for ending the use of fossil fuels and to keep being on the side of people in communities like Pittsburgh and Richmond who are going to be the most affected if there are these kinds of proposals that go ahead and create pollution, more pollution for those areas.
Mhm. Yeah. Imagine if, oh, okay, some hands up. Susan was first there.
Well, thank you very much, Ilana. And Jackie, can you share information about the legislation that you just mentioned about agriculture and
Yeah, the first one, which I mentioned yesterday in my presentation, is the 30 by 30 initiative. So the state of California just passed legislation trying to protect, mandating the protection of 30% of our land and our water by 2030. In California, we have a lot of open spaces, and so I think we'll make it. There's also a lot of legislation on basically like carbon farming. This is another thing, Alana, that would be interesting to know. There's a lot of crops that people are looking at, like switchgrass, where they would grow the crop in order to store carbon and then harvest the crop. I'm not sure what it would be used for. And so there's agricultural methods of carbon storage, also, as Alana mentioned, no-till farming and cover crops. But there's kind of even more specific things than that. Like in the future, we might have, in like the sci-fi world, we'll have people who are carbon farmers who are storing carbon, and maybe also people who are water farmers who are creating basins and agricultural land and catching water, making lots of ponds to help refill aquifers. So there's things like that. Those are initiatives that are being studied right now.
Okay.
And the Biden administration also has a 30 by 30 initiative, but I don't think that has passed. Let's see. And I think Mary and then Sherry were next.
Thanks.
Thanks. I have two things. One is any of this information available in Spanish, Vietnamese, Hmong?
No, not yet. Right now, the Center for Biological Diversity has started a campaign to oppose Montezuma Wetlands. And so we're a partner following the process of, right now there's been an application to the EPA, and it was sent back for the EIR being too vague. And then another application went in and they said, hey, this is still too vague. So we're following. So there's petitions to sign. Things will come out more over the year. It's a really complicated project because it crosses a lot of jurisdictions, right? It's on land, it's in water, it's in multiple counties, in multiple cities. It has to do with PG&E and refinery. You've got
And all that blocks translation into Spanish?
No one is that far along. I mean, there's no one, right? You have to remember, environmental activists are generally unpaid. Everything we're doing here today and all week is just as our volunteer process. So the people to ask for that would be the Center for Biological Diversity, and you can go onto their website. I would guess that this is much too new to have any kind of literature to spread on this. Because, when it's time for people to show up for hearings, especially people in those disadvantaged communities where the stuff might be stored underground, might be injected into wells underground, that's when we need to get people out to meetings. And that's where you reach out to the community members in different languages, because they can show up and speak in whatever language they do, because there are translators there. And I have seen that at CARB meetings where there's a lot of people speaking actually Hmong and APEN, the Asian Pacific Environmental Network, activates a lot of people to come out, and they'll speak in their native languages at these meetings, and Spanish speakers also. But I think in terms of just informing people about this project, it's brand new. It's brand new hearing about this for us.
The other thing, can I just add the other thing? I'm right now taking the class with UCANR called Climate Stewards, which is in a way indirectly how I found out about this. And we went to the Forest Genetics Lab near Placerville, and they talked about reforestation, especially after wildfires. And the bad news is that trees are very slow growers, and they're extremely picky. So it's very hard even to do hybrids across different kinds of tree species. So if you try to plant a lot of trees to sequester carbon or come back from a fire, they're very slow and picky. It's not a real practical to depend on. That's the bad news.
Which is why we're looking at carbon capture and storage, which is why our government is looking at that. And that's also why farmers are looking at cover crops, as I mentioned, like switchgrass, because it's much faster in a growing season. They just take it out. And then usually, I have to say, they burn the biomass for energy, is what they do with it. Is they call it clean energy because it's sequestering carbon and then they're burning it, which is kind of what they're doing with biofuels too. They're calling it clean energy because they grow it from the ground. But I don't think we accept that because it still releases a lot of pollution. All right, Sherry, thank you for your patience.
Oh, sure. And that's why they call natural gas, which is actually methane. All my friends say, well, why then is it called natural? I said, well, it's not dirty and ugly. You know, when it comes out the tailpipe, you don't see it, but it's not. Anyway, quick question for you guys. As far as keeping sync with the Montezuma Wetlands, what would be the best resource? Would it be your guys' newsletter or what? Just to kind of keep abreast of what's, transpiring and stuff.
Yes, I don't think we've put anything in the, have we put anything in the newsletter? Well, here's what you should do. You should sign up for our newsletter because we've actually already posted links to presentations that were only on the Montezuma Wetlands. So the Center for Conservation Biology, they have someone who is giving dedicated talks on this project. And we could probably get a hold of the slide deck to share that with people, or recordings of the entire presentation. Alana just gave part of it. It's a little more in detail with the people from the Center for Biological Diversity. And again, they have paid staff, but then they have asked for volunteers, and that's like where 350 Contra Costa comes in, that we're a little bit more grassroots. And so we get out and tell people about things that are happening, because all of the environmental organizations are pretty limited in who they reach. So we all share, we all work in coalition to get words out about projects.
Thank you.
But yeah, you could email us and ask for follow-up information about it, or you could even join us and be a representative, because we have a monthly meeting on Montezuma Wetlands that is sponsored by the Center for Biological Diversity. It's a really big coalition, and once a month for an hour, you could go and hear what the latest is with the lawsuits and the actions and the planning to educate people by sending letters to the editor in your local paper. We have a few representatives who go from that, but there's always room for more people and more work to do on those kinds of outreach campaigns. And that's exactly how 350 Contra Costa works with local volunteers, that we get in, We go to lots of meetings, we educate ourselves, and then we share our information in presentations like this, or through petitions or protests or letters to the editor, and whatever the tactic is for that campaign.
Great, thank you.
Yeah, and if you watch the presentation I gave yesterday, it talks more about climate campaigns and what a climate campaign is and how they all have similar structure. And a lot of them go on for very, very long, like a decade. But some of them are just 1 or 2 years, but they're all super interesting. And everybody here, just the fact that you're here at this meeting, you're like taking a climate action, you're getting educated, and you definitely have skills that you could share with your wider community to educate people about environmental issues. And that's just what grassroots organizations do. All right, well, thank you so much. And feel free to reach out to us again by email at 350contracosta.org. And we also have a website, 350contracostaaction.org. That's probably a little better. It's our more recent website. We also do some electoral work and support climate candidates, and phone banking, get out the vote stuff. But our main focus—
And work on legislation.
Oh, and a lot on legislation. So Alana does a lot of work on legislation. So as I said yesterday, again, legislation is really our bread and butter. We work with 350 Bay Area, which is our mothership, and we work with 9 other counties around the Bay, and we follow California state legislation. We write letters, we do direct lobbying. We have lots of lobby meetings. We met with DeSaulnier last week. The month before, we met with Rebecca Bauer-Cahan. We meet with Senator Glazer's office, and we do these things, boy, every single month during the legislative season. We call office staff of the sponsors of the bills. We follow out, we ask them, what do you need done? Who do you need to be contacted? Or do you need us to come to a meeting or a hearing? And then we rally support, and we get people just like you and me to call in and give comments. And we know from talking to the people we work with that this really makes a big difference to legislation, to show constituent support. Allison says, how can we get the presentation? As Albert said, it will be posted onto the library YouTube channel in just a few days. And 350 Contra Costa also has a YouTube channel. It will take at least a week or 2 to get it on there for us. And again, we can give you more resources on our YouTube channel. We have connections to our past presentations on all different topics. Education is a lot of what we do. I think this is my 3rd program in a month or something. And there's just things happening every month because climate is such a huge topic. There's a lot to know, and there's so much really interesting stuff. I mean, it certainly doesn't get boring.
Request, can one of you put the library YouTube channel link on the chat?
Yeah, Albert,
Yes,
can you do that?
I can add that right now.
Okay, thanks.
And then everybody will get the link again in an email.
Right.
So I'm going to give you our channel that takes you to all of our videos in just one moment.
Yeah, and I'm typing in the our website where you can sign up to get newsletters or be a volunteer. Oh. There it goes, and it's not a live link, so you'll just have to copy paste it. Anything else to close, Alana? Are you?
I'm going to put in the link for our survey.
Oh, great. Do you want to tell everyone a little about the climate survey?
Yes, just a second. Sorry. Where am I? Here I am. Okay. The survey is just, is a 4-question survey. We're just trying to get a general feeling for what people are, how people view the climate crisis. Yeah, that's it. Just for, and if you enter, you will be entered in a raffle to get one of our lovely t-shirts.
Could you put it back up, please?
Yeah, I will. I haven't put it in yet. I'll put it in the chat.
And again, thank everybody for joining us. Let's see, I'm waiting for Alana to drop this before we close. So you can open
Right.
the survey.
Hold on.
No, not yet.
Oop.
No?
I got it.
Okay, I was gonna say, maybe we can also give it
Here
to,
it is.
you got it? Okay, let me see. I'm not seeing, oh, there it is. Okay, she's got it. There's a Survey Monkey survey in there. So yeah, we'd really welcome it if you open that and tell us what you think about climate. All right, everybody, thank you for joining us. And I hope
Thank you very much.
Thank you so much.
to the older
Thank
presentation.
you.
Okay,
Yeah.
have a good
Bye.
afternoon. It was a good lunch and learn. Thanks, Alana.